We're going to do some review practice problems for Chapter 2. So first we have here some domain problems. So can you find the domain of f? So what we want is for what's inside that radical to be greater than or equal to 0. Now you can't just add the x squared to the other side and square root both sides with an inequality. That is not going to be an acceptable way of solving this. So I need to see that you're going to factor that, and then we're going to do a number line where this is equal to 0 will be at -4 and at +4. Because of the or equal to, we will put solid dots. We can test each of the three regions. When you plug in something from the far left region, like -5, 4 minus -5 is positive, 4 plus -5 is negative, positive times a negative is negative, and that is not greater than or equal to 0, so there will be nothing in the domain left of -4. A representative from the middle can be 0. 4 minus 0 is positive, 4 plus 0 is positive, positive times positive is positive. That makes everything in between -4 and 4 a solution, therefore part of the domain. A representative from the right, say 5, will make the first term negative, but the second factor is positive, and a negative times a positive is negative, which is not greater than or equal to 0, which is then not going to be in the domain. So our domain is going to be -4 less than or equal to x less than or equal to +4. Similarly, we're going to take the x squared minus 9 for g and make that greater than or equal to 0. Again, we're going to have to factor because of the square term. We cannot, with an inequality, just add it to the other side and square root both sides. We're going to have to do a number line, and I'm going to need to see this if you're going to get credit for it. That's going to make 3 and -3 the boundaries of our domain. When we plug in something to the left, like say -4, -4 minus 3 is negative, -4 plus 3 is negative, negative times negative is positive, makes everything to the left part of our domain. Plugging in 0 makes 0 minus 3 negative, 0 plus 3 is positive, and a negative times positive is negative, so that's not in our domain. Plugging in something like 4 makes both terms positive, their product is positive, making everything in the domain here. So just as we have two pieces, we're going to have to write two separate inequalities. X less than or equal to -3, we need the word or. X greater than or equal to +3. There is no way to write that correctly as a double inequality like we saw there. Now, I'll briefly talk about range. When I ask you the range, I'll let you use your graphing calculator. When you graph f, so looking at f, you're going to have to, even though you're using your graphing calculator, you're going to need to do a little interpreting. So if you put in y equals square root of 16 minus x squared, your calculator is trying to draw a semicircle, but these parts in here may not always show up. So it may look like that is actually stopping short of the x-axis, but that's just the limitation of your calculator. If you hit trace and then type in, you'll get x equals 4, it will move the cursor right to this point, and on the bottom of your screen, you'll see that y equals 0. Since it gives you a number for y, that is in fact on the curve, even though it may not look like it. So in fact, our y values are going to go from 0 to 4. So our range is going to be y less than or equal to 0 less than or equal to y less than or equal to 4. For g of x, if you try to graph that on your calculator, it's trying to do something like this. So we'll talk about this at the very end of the year, how to graph this pencil and paper. But that's half of a hyperbola. Again, it may not be clear what's going on here. It may look like the graph stops short. But again, if you hit trace and then type in x equals 3, you will see that y equals 0 is in fact part of the curve. So since it goes forever up, then our range will be y greater than or equal to 0. Okay, so let's do some other domain questions. So these will come up. So can we find the domain of h of x equal to the square root of x plus 1 over x minus 4? So again, we're going to need a number line as we did in those first two problems. The place where this could change from positive to negative is where the function is equal to 0, which is going to be negative 1, and where the function will be undefined, which is going to be 4. So at negative 1, we're going to get 0, which the square root of 0 is defined. At 4, the function is going to be undefined, so we're going to get an open circle. As we saw in the earlier f and g domains, we're going to test each of the three regions. If we plug in, say, a negative 2, then the numerator is going to be a negative 2 plus 1 is negative, and the denominator is negative 2 minus 4 is negative 6, and a negative divided by a negative is positive, which means these are going to be in the domain. If we plug in something in between negative 1 and 4, 0 is a nice choice. We'll get a positive numerator and a negative denominator, which is going to make the quotient negative, which is not going to be in the domain. And plugging in something from the far right region, like say 5, we're going to get a positive over a positive. That is going to be defined, and so that will be in the domain. Once again, we're going to see a domain in pieces. X is less than or equal to negative 1, or x is strictly greater than 4. Let's do another domain question. Let's do 1 over, and we'll say x squared minus x minus 2. So this will be undefined when the denominator is 0. So the question becomes, where is x squared minus x minus 2 equal to 0? If we factor that correctly, we'll get positive 2 and negative 1. So when x is 2 or negative 1, we're going to get a divide by 0, which is undefined, so our domain can be anything except for 2 and negative 1. Another example is, say, j of x is equal to the natural log of x minus 3. So the issue with a logarithm is sort of like a radical, except in that it cannot be negative, but it can't be 0 either. So we get x minus 3 is strictly greater than 0. Solving that gives us x is greater than 3, and that is our domain. So if we do another example, say m of x is equal to, we'll say 1 over, and we'll go the square root of, and say, let's go 25 minus x. So the issue here now is two things. We can't be a negative inside the radical, but we could be 0 and still have the square root defined, but because that's also in the denominator, it can't be 0 either. So we're going to get that 25 minus x must be strictly greater than 0. And if I add the 25 to the other side, we're going to get x is less than 25 for our domain. I'm going to change screens here.